This week, you're going to be doing problems based on the sections in the book 4.1, 4.2, and 4.3. 4.1 and 4.3 are all about analyzing functions using calculus. So we're going to be doing things like looking when a graph is increasing, like going up, or decreasing, going down. There's these things called concavity. If you have this N shape that I have right now on the screen, that's called concave down. If it turns a little bit like this, that is concave up. Although I didn't draw the complete U shape that you might see in a lot of concave up, it definitely starts to have that left side of the U. There, I kind of put it in red. You can see that that looks like part of a U, whereas the other portion that I have over here in green is an upside down U, or maybe an N shape. So that would be concave down. The red guy is concave up. At some point, it has to switch between concave up and concave down. And that switching point has, of course, a name. It's called an inflection point. So you're going to be using calculus to find increasing, decreasing, concave down, concave up inflection points. And the big idea here is you're going to be finding critical numbers. Critical numbers are an x value where either the derivative is equal to 0 or the derivative is undefined. That's almost always where we start when we do analyzing functions. You are going to have to recall some of the previous work you did in this class, like finding intercepts. Here's a y-intercept. Here's an x-intercept. And asymptotes. Maybe this graph has a vertical asymptote over here, or maybe it has a horizontal asymptote over here, depending on the type of graph. You will be asked also at times to find asymptotes and intercepts, which we have in previous sections. 4.2 is about these two theorems called Rolle's theorem and mean value theorem. They're not used a lot, except perhaps in other proofs. The reason why they're here in this section is because, as I mentioned, critical numbers are very important in 4.1 and 4.3, and they have to do with values of the derivative, whether the derivative is 0 or the derivative is undefined. And these theorems, Rolle's theorem and mean value theorem, tell you that we're going to have, under very simple conditions, definitely places where the derivative is equal to 0. We can find critical numbers for most functions, and that's what Rolle's theorem and mean value theorem is about. It's not a fruitless search to look for when you have a critical number. You're guaranteed that there's a critical number. You just have to use some algebra to find it. Once again, if you have any questions, please let me know so I can help out. I do have tutoring hours every day, Monday through Thursday. And of course, you can reach out with email. All right, have a good day and good luck.